All right, sample exercise 5.4. How much heat is released when 4.5 grams of methane gas is burned in a constant pressure system? All right, so what we have here is a chemical reaction where we are combusting methane, which is a combustible gas, and they provide the balanced chemical equation for you, so that's nice of them. Not always, that won't always happen, so there are times where you may have to predict the products of the combustion reaction, but I know you're all experts. You'll be just fine at doing that. And they also give us a delta H value. They tell us for every 1 mole of methane that reacts with 2 moles of oxygen, yields 2 moles of water and 1 mole of carbon dioxide, that process releases a total of 890 kilojoules of energy. I know that it released energy because the value of delta H is negative. If the value of delta H was positive, then that would mean that energy was absorbed during this process. So this is kind of a mix of stoichiometry with thermochemistry, two big words to mean a simple process. We are going to use the balanced chemical equation, the mass of methane, and the amount of energy that's released by 1 mole of the methane to determine the overall amount of energy that's released by 4.5 grams of methane. So having said all that, we will begin the problem here. All right, so I'm going to start off writing down what they give me, which is 4.5 grams of CH4. Like we usually do with grams when we're dealing with stuff like this, we're going to convert it to moles. So 1 mole of CH4 has a mass of 16 grams. And then this step is a little bit different. Usually at this point we do a mole to mole ratio or something, but that's not what we're solving for here. We want to know, according to this balanced equation, how much energy is released. So according to the equation, the coefficient for CH4 is 1. So 1 mole of methane releases 890 kilojoules of energy. So that's a new concept there, going from moles to energy versus a mole to mole ratio or moles to grams. When we do the math, we find that this is negative 250 kilojoules of energy, or we can say that 250 kilojoules of energy was released. And that's about as difficult as those problems get. Now, if for some reason there was a coefficient in front of CH4, let's say that when you balance the equation, there was a 2 in front of here, you take that into consideration at this point. So in this case, it was only 1 mole of methane released the 890 kilojoules of energy. But if it was something other than 1 mole in your balanced equation, that would reflect right there. You'd use that coefficient and say, okay, 2 moles of CH4 release that much energy according to the balanced equation. But since this one was only 1, we did the 1 mole to energy conversion.